Now let's try to see the relation between asymmetric and irreflexive relations. So when we are talking about asymmetric and irreflexive relation, it is interesting to note this point. If a relation is irreflexive, then what happens is there will be no diagonal elements in that, isn't it? Now if a relation is asymmetric, there will be no diagonal elements at all. So using this, maybe you can write something like this: every asymmetric is irreflexive. Think about it. Every asymmetric relation is irreflexive. So how did I write this? By intuition, nothing else. So if you practice more questions, if you see all these videos, even you'll develop this intuition. So every asymmetric relation is irreflexive. Is it true? Is it true? So how can I write this? If a relation is asymmetric, then definitely there will be no diagonal elements in that. And so if a relation does not contain any diagonal elements, then it is definitely going to be irreflexive. Now can I write the other way? Which means, can I write like this: every irreflexive relation is asymmetric. Can I write it like this? Now see this: if a relation is irreflexive, there will be no diagonal elements at all. So if there are no diagonal elements, then is it definitely going to be asymmetric? Need not be. The reason is, there can be some irreflexive relations which may not contain diagonal elements, but they may contain symmetric pair. Therefore that particular relation may not be asymmetric. For example, I'll give you one irreflexive example like this. Let us say a relation R is containing two ordered pairs 1, 2 and 2, 1. It definitely does not contain diagonal elements, but it does not mean that it is going to be asymmetric. The reason is, even though it does not contain diagonal elements, what is happening here is, it is having 1, 2 and 2, 1, which is symmetric pair. So because of this presence of symmetric pair, it cannot be asymmetric. Therefore the second statement is wrong. Okay, now since you found out the first one, whenever you have any such relation, we can imagine that one set is properly included in the other set. Right, now again there will be a confusion. So which one is included in what? So is this diagram right? Which means, is the outside one irreflexive and the inside one asymmetric, or is the inside one irreflexive and outside one asymmetric? So we don't know which one is right. The reason is simple. Following this, now from this statement I know that one set is properly included in other set, and most of you will think that since every asymmetric relation is irreflexive, maybe this is right. Okay, so we don't know which one is right. So let's see how to evaluate it. Now which one do you think will be bigger and which one do you think will be smaller? Right, if you can answer it, then we can easily answer it. Or can you find out any relations which are present here? Then you can easily answer it. So one simple one is, you try to find out a relation which is going to be irreflexive but not asymmetric. If you can answer it, it is done. Right, so can you find out any irreflexive relation which is not asymmetric? Yes, this one. This is irreflexive relation which is not asymmetric. Therefore this is right, isn't it? Then why is this one not right? Because if you find out a reflexive relation, then it has to be asymmetric. But then see this example, this is a irreflexive relation which is not asymmetric. Therefore this diagram is right. Okay, so how to find it out? Just by counter examples only. So it will be really a confusion in almost all the subjects. So whenever I talk about this point in any subject, then whenever I try to present these diagrams, there will be a lot of confusion. So how to see this confusion? Simple. You try to find out, you try to justify it. You try to find out a relation which is irreflexive and which cannot be asymmetric. right? And this is the example. Therefore this area exists. Now you try to find out a relation, or you try to prove it wrong. Okay, you try to find out a relation which is asymmetric and which is not irreflexive. If a relation is asymmetric, definitely it is going to be irreflexive. Therefore you cannot find any point here. Or you can see that, if a relation is irreflexive, it need not be always asymmetric. That is the example. So using counter examples you can derive which one is right. Okay, it is always confusing, but with practice you will understand it. Fine. Now let us say this is a set of all relations possible, universal relation, right? And we already know what is n of I. We already discussed it, right? I am not going to do it again. So even if you want to do it, yes. So number of irreflexive relations, n of I is going to be 2 power, I already derived it, that is why I am not deriving here. Okay, 2 power n into n minus 1. This is the number of irreflexive relations. And the number of asymmetric relations, we have also derived this, which is nothing but 3 power n into n minus 1 by 2. Now we know n of I and n of a, so we can easily answer all the questions. So what are all the questions possible? What is the number of relations which are either irreflexive or asymmetric? Now if you observe this from the diagram, you can see this, right? If you don't have this diagram, you don't know how to solve it, and you might end up using n of I union a is equal to n of I union n of a. But then here if you see this, n of I union a is simply n of I, isn't it? Number of irreflexive relations. So which means the number of relations which are either irreflexive or asymmetric is going to be number of irreflexive relations itself. And similarly, number of relations which are going to be both irreflexive and asymmetric is going to be n of a, which means n of I intersection a. The number of relations which are both irreflexive and asymmetric is nothing but number of asymmetric relations itself. And similarly they might ask you number of relations which are irreflexive but not asymmetric. Then you have to see m of, they are asking about this region. Let us say this region is 1, this region is 2, this region is 3. They are asking about region 1. It is nothing but n of I minus n of a. So first of all, can you justify these regions? Which means, can you tell me one relation which is irreflexive but not asymmetric? Yes, R1. This one is justification for region 1. Can you tell me a relation which is example for R2, which means which is both asymmetric and irreflexive? So yes, anything like this. Now can you tell me the relation which is not irreflexive and which is not asymmetric? Yes, if it contains at least one diagonal element, then you can say that, isn't it? Now all the regions are justified. Therefore, can you say the number of relations which are asymmetric but not irreflexive? It is going to be 0. The reason is every asymmetric relation is going to be irreflexive. Therefore, we cannot distinguish them, right? And then what is the number of relations which are neither irreflexive nor asymmetric, which means neither irreflexive nor asymmetric? So it is going to be n of u minus n of I union a, right? And we know that n of I union a is nothing but n of I itself. Got it? So region 3 is nothing but from n of u, if you subtract n of I, that is going to be region 2. And what is n of u? 2 power n square. Got it? So this is how you can find out the relation between asymmetric and irreflexive relations. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay, IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.